Let's say if you have force time for a particle is given as we have this force versus time graph. This particular term is defined ut, or you can call it as t naught. This particular term is defined nothing but f naught. So you have to find impulse related to this curve. Find first impulse. Second, if initial velocity of object is u, find final velocity if mass of body is m. So how to define first part, impulse? In last class, I have explained you impulse is nothing but area under force time graph. Okay. Impulse was f times dt integration. If two quantities are related by a product, so in term of graph, it will define you nothing but area. So we can call it as area under force time graph. Is it clear?
Yes, sir.
Now we have to find area of this particular curve. In third chapter, I had explained you if you have to calculate area related to any curve, whether it would be circle, ellipse, any curve, its area would be pi times r1 into r2. R1 would be along x-axis and R2 would be along y-axis. So from this you can conclude from this point to this point is nothing but diameter of this particular curve. And similarly, from this point to this point is nothing but radius in other coordinate of this particular curve. So let's say this is your diameter. So if you take it half, or if you break it half, so it will be R1 is equals to d0 by 2, and R2 radius corresponding to the y coordinate, it will be f0. And since this curve is nothing but half of a circle, so its area would be pi R1 R2 divided by 2. So from this you can say impulse is equals to pi R1 into R2 over 2. Pi by 2, R1 is radius along x coordinate and it is d0 by 2. R2 is radius along y coordinate and so on simplifying you will get pi by 4 times f0 into t. Is it clear to you all?
Yes, sir.
Ishma, in doubt?
No, sir.
In the next part, we have to find final velocity of object if its initial velocity is u and mass is m. So using impulse momentum theorem, I have explained it in last class. Impulse is nothing but change in linear momentum. So you can say impulse is equals to change in linear momentum, which is equals to mass times final velocity minus initial velocity. We have just calculated impulse as this. Just put it here. Move this mass to the other side and u to the other side, you get the value of p. Try to simplify it. Have you all done? If you put the value of impulse here, you will get m times v minus u is equals to pi f naught t naught divided by 4. Move this mass to the other side and u to the other side, you will get final velocity is equals to initial velocity times f naught t naught divided by 4 times of m. So this will be a final expression of final velocity. Is it clear to you all?
Yes, sir.
Yes, sir.
Okay. Have you all written to this part? Hiba?
Yes, sir.
Okay. I'm giving you one more problem regarding it.
Sir, you can show again that slide again because I just finished it last part. Okay, sir.
If you have a curve like this, This is displacement versus time, 4, 2, 4, in terms of meter, in terms of second. For an object having mass m, so we have to calculate, find impulse at t is equals to 2 seconds. Impulse is nothing but change in linear momentum. So for the change of linear momentum, you must have to define two different velocity and 2 seconds. But from this curve, if you visualize, we have just one point at this, at this. So how to define two different velocity so that you calculate impulse? For this, I'm giving you one relation. So to find velocity change at this instant, just move a little behind or move a little ahead to this particular curve. Let's say at this point or at this point. For a straight line, its inclination would be constant or its slope would be constant for its entire path. Let's say if you have calculated inclination or slope at this point, or at this point, its inclination or slope would be constant. And as we know, displacement versus time, it's define you velocity. So if you calculate velocity at this instant, let it be like this. It must be inclined at some inclination theta. So you can call it as V1. So if you calculate at this point, at this point, at this point, or at this point, all of the inclination or slope would be remains constant, as this particular curve is a straight line. So for a straight line, its slope is constant. So if you have to calculate slope, I have defined you in terms or in graph. Slope is nothing but y2 minus y1, x2 minus x1. So from this graph, if you check coordinate of this point, it will be 2 and 4. For this point, it will be 0, 0. So if you have to calculate v1, it will be y2 minus y1, that is 4 minus 0, x2 minus x1, 2 minus 0. So it will be 4 upon 2, that will be 2 meter per second. Is it clear till this part?
Yes, sir.
Yes, sir.
One little question. I'm still
Yes,
thinking,
Salman.
how did you get the 4 up there? X on the x-axis. No, sorry, y-axis.
I've just, okay, I've
Therefore.
just defined you. For this straight line, slope or inclination of a straight line is always constant. If you calculate it at this point, this point, this point, and this point, it will be remains constant for the entire path. So I have taken this triangle in which if this is 2, so corresponding to this is 4 here. That's why I have taken the coordinate of this point to be 2 and 4.
No,
Okay.
like I understand that. I'm like on the y-axis, there's a 4, right?
Yeah,
Yeah, how did you get that? That's what I'm asking.
it is already given in the question.
Oh,
For this peak, we have x is 4 meter. Okay.
yeah.
It is already in the question. So your x coordinate from this point to this point for this particular peak is 2, and y coordinate from this point to this point would be just 4. So its coordinate would be 2, 4. Is it clear?
Yes, sir.
Similarly, if you calculate slope for this line, whether this point, or at this point, you get the same inclination inclination or same slope. That's why I have defined straight line to this point and drawn a horizontal line to it. So this inclination will define you velocity v2. So for this line, coordinate of this point would be 4 and 0, and coordinate of this point would be 2 and 4. So this will be your x2 y2 and this will be your x1 y1. So from this you will calculate v2 is equals to y2 minus y1 x2 minus x1. So it will be minus 4 over 2, which is equals to minus 2 meter per second. Is it clear? Ishma,
Yes,
is
sir.
it clear?
Yes, sir.
Okay. So we have just calculated V1 and V2. So in this part, we have to define impulse, or which is nothing but change in linear momentum at this particular instant, which is 2 seconds. So just move a little bit behind and a little bit ahead and find their inclination with respect to x-axis. Since this particular graph is in relation of x and t, whose slope will define your velocity. That's why I've calculated v1 and v2 from this. Now, impulse is nothing but change in linear momentum. So it would be mass times v final minus v initial. V final is v2 and v initial is v1. On putting these two values, you will get minus 2 minus 2, it will become minus 4m. Is it clear? Khalid, do you have any doubt?
No, sir.
Okay, just write it down. Have you all written?
Done, sir.
Salman, have you written?
Yes, sir, done.
Ishma,
Yes, sir.
next is third law. It is nothing but if you apply a force, or for every action, there must be an equal opposite reaction. So you can say for every action, there is equal and opposite reaction. But this action and reaction acts on two different bodies, so they will never cancel out. As action and reaction acts on two different objects, so they will never cancel out. Now, on the basis of this third law, we have to define first how to calculate normal reaction, or what do you mean by normal reaction? There is two different meaning of this particular normal reaction. First, if you have a block on a particular surface like this, so this block having some mass m must be exerting some amount of force on this particular surface due to its gravity. We call it as mg. So in turn, to balance this particular gravity, as this block is not going down, this surface must be applying some force against this particular action in opposite direction. We call it as normal reaction. So from this you can say normal reaction is nothing but a force to balance its gravity provided by the surface. Okay? So it will be a reaction force provided by surface against gravity to balance it. So for this particular normal reaction, there should be always a surface. If there is no surface, there would not be any normal reaction. Is it clear? Ishma, is it clear?
Yes, sir.
There is one more concept of this normal reaction. Let's say if you have a block like this, and there is another block attached to it like this. So when you apply a force at this point, let's say F, this block would move forward, so it will must apply a force to this block due to its contact or due to its surface in contact with these two points. Then this interaction, when this block provide force to this block like this is called action provided by this block to this. In return, this block would also provide a reaction in opposite direction. So the force which is in between two surfaces of contact is called normal reaction. So again, this particular interaction is also called normal reaction. The force in between contact of two surfaces. Is it clear, Hiba?
Yes, sir.
Just write it down.
Done, sir.
Hamza, done?
Yes, sir. Done.
Salman?
Done, sir.
Okay. I'm defining you some tips how to solve problem. Solving problem. Let's say I'm giving you a problem. This is your block A. This is your block B, having different masses. Placed on horizontal surface, which is frictionless. A force of 12 Newton is applied along this direction, and a force of 2 Newton is applied along this direction. Let's say this block is of mass 3 kg and this is of mass 2 kg. Let's say this is A and this is B. So we have to calculate normal reaction between A and B. Find normal reaction between A and B. So for any of the problem, first of all, take this entire system to be as one block system, like this. And then apply the forces. So we have one force along this direction, which is 12 Newton, and one force along this direction, which is 2 Newton. And entire mass of the system is 3 plus 2. Since this force is stronger as compared to this one, so it will accelerate this system along this direction with some acceleration A. Is it clear?
Yes,
Ishma?
sir. Yes, sir.
Okay. Now we have forces, mass, and we have to calculate acceleration. So using second law, you can say F net is equals to total mass of object into acceleration of system. If you have to calculate acceleration of system, move this mass to the other side, you will get acceleration of system is equals to net force. We have 12 Newton in right side, so take it positive. 2 Newton in left side, so take it negative. So you will get 12 minus 2 divided by 3 plus 2 as total mass. So it will be 5 kg. So it will be 10 over 5, which is equals to 2 meter per second square. So first of all, try to find acceleration of system using second law. Is it clear? Hiba, is it clear?
Yes, sir.
Sir, what does A symbolize again? Acceleration of the system?
A is nothing but acceleration of system. Yeah.
Okay.
I have assumed this particular two block as combined one block system and combine their masses. So it will become 5 kg and apply the forces from either end and calculate it using this second law. Is it clear, Khalid?
Yes, sir.
Okay. Now, we have to define one term that is called free body diagram. Free body diagram, or you can call it as FBD. FBD is nothing but a representation of all forces acting on that particular object along or opposite its direction of motion. So FBD is nothing but a representation of all forces acting on body along its motion. So from this, if we define for 3 kg block and 2 kg block individually, so we have 3 kg block and 2 kg block. On 3 kg block, one force is acting from left side, which is of 12 Newton. If this A would apply a force on B, that is called action. So in return, B will apply a reaction on this A. We can call it as force on A due to B. Is it clear? This particular block having mass 3 kg, since the whole system is going along the right side, so each block must move along the right side having same acceleration as of the whole system. Now apply second law for this part. So it would be A is equals to net force, that is 12 minus FAB, divided by mass of the block, that is 3. Put the value of A to be 2 meter per second square and simplify, you will get the value for FAB. So A is 2. If you move 3 to the other side, it will become 3 into 2, that is 6. So on simplifying it, you will get FAB is equals to 6 meter. Is it clear to you all till this part? Salman, is it clear?
Sir, can you like tell after A is equal to 12 minus FAB by 3? After that, what did you do for getting 6 Newton?
I have just put the value of A to be 2 meter per second square here. Move this 3 to the other side. Here it is in denominator. On moving to the other side, it will move to numerator. So it will become 2 into 3. So it will become 6. Move FAB to the other side and 6 to the other side. It will be 12 minus 6, that is 6 Newton for FAB. Okay.
Okay.
Now, similarly, if you do for 2 kg block, there would be a force along this direction, which must be applied by A on B. So you can call it as force on B due to A. And we have another force along this direction that is of 2 Newton. As the whole system is going along the right side with same acceleration A. So apply the formula. A is equals to net force, that is FBA minus 2 divided by mass of the block, that is 2. So you will ask why I have taken FAB first, then 2 as second. As the acceleration is going along the right side, so the force which is along this particular acceleration would be greater in magnitude. That's why I have taken this particular force to be stronger as compared to this one. Now, if you put the value of A to be 2 and move this 2 to the other side, you will get 2 into 2 is equals to FBA minus 2. Move this 2 to the other side, you will get FBA is equals to 6 Newton. Now just see in this part, if FAB is 6 Newton and FBA is also 6 Newton, so if this is your action, this must be in reaction on A by B. So from this, I have just proved action reaction for any two different body must be equal. Is it clear, Khalid?
Yes,
Ishma?
sir.
Hiba, do you have any doubt
No, sir.
till this part? Okay, just write it down. Have you all done till this part?
Yes, sir. Done.
Ishma, done?
Yes, sir.
I'm giving you one problem and try to simplify it. If you have a surface like this on which a block, this, another block, this, force of 10 Newton along this direction and a force of 4 Newton along this direction is applied. This is of 2 kg and this is of 1 kg. Let's say A and B. Find first acceleration of system, second force on A by B. Try to simplify it as we did in the last part. Good, Salman. Ishma, send your answer. Ishma, just check your calculation. Check your second answer, Salman. Ishma. Hamza, send your answer. Khalid, just send your answer. Good, Hamza. Good, Salman. Good, Ishma. So you have to take this system or this two block term as single body system. So 2 plus 1 becomes 3 kg as whole. We have one force along this direction, 10 Newton, and one force along this direction is 4 Newton. So acceleration of system from this part would be good Hiba 10 minus 4 divided by 3. So it will be just 2 meter per second square. Now use FPT. One is along this direction and the system is going along this with some acceleration A. So there would be a force along this direction, force on A by B. So using second law, you would say A is equals to 10 minus FAB divided by mass of block, that is 2. A is 2 into 2 is equals to 10 minus FAB. So FAB is equals to 10 minus 4, that is 6 Newton. Khalid, is it clear?
Yes, sir.
So this, There is one more term in this part that is called tension. Suppose you have a support and you have attached a string to it. So it will be hanging like this, slagging. Due to its slackness, there is no strain in this particular part, so tension would be 0. But now, if you attached any block to this particular string, it will become straightened like this. If you attach any block to this point. Initially it was slagging, but now it has become straightened. So the force which arises in any string, rope, wire due to its straightness is called tension. So tension is nothing but a force which arises due to its straightness is called tension. Now, how to define tension? First, for any massless string, tension would remain same at each point. For massless, inextensible string, tension would be same at each point. Third, it always acts opposite to the point of contact. It always acts opposite to the point of contact. Just in this part, we have two different points of contact. First, at this point with the string and block, so it must be acting opposite to it like this. And we have another point of contact at its highest point, so it must be acting opposite to it like this. As this string is massless and inextensible, so tension at this point and tension at this point must be equal. Since mass of block is n, so it must be experiencing a downward force that is mg. As the block is not accelerating in upward or downward direction, so total upward force must be equals to total downward force. So from this, you will say tension must be equals to mg. Is it clear to you all till this part? How I
Yes,
have defined this tension? Iba, do you have any doubt?
No, sir.
Okay, just write it down. for massless inextensible string, and if it is same, then tension would be same at each point of contact. I'm giving you some clue how to solve this. Have you all written to this part?
Yes, sir. Done.
Hiba, done? Salman?
Yes, sir. Done.
Yes, sir. Done.
Okay. So for any of the problem, first of all, make the whole term or whole different block as single block system. Let's say like this. So it will be take this whole block as single block system and apply the forces which are acting on it. A force of 12 Newton along right side and a force of 3 Newton on left side. 2 plus 1, it would have total of 3 kg mass. Since this force is going along right side and having larger in magnitude, so acceleration of system must be along this direction. So using this, just apply second law, you would find acceleration. Now, after finding acceleration, use the concept of FBD. Then, for this 1 kg block, which is experiencing a force of 12 Newton along a right side, and due to contact of string, it must be experiencing a tension in opposite of contact towards left side. And since the system is going along right side, so this block must be moving along right side with acceleration A. And the mass of this block is 1 kg. So again, apply the second law and try to find tension from this. Is it clear? So from first equation, you will calculate A, put it in the second equation, you will get the value of tension T. Try to solve. Good Salman. Good Ishma. Good Ishma. Good Salman. Hamza, send me your answer.
Sir, T is correct, which I sent.
Yeah.
Uh, uh,
Hamza, you have to find acceleration first from this equation, then put this acceleration in second part here to get the value of t. I think it would be positive. Hamza? A is
okay, sir.
equals to
Just let
net
me do it
force.
again, sir.
A is equals to net force, that is 12 minus 3. Divide by total mass, that is 3. So it would be 12 minus 3, that is 9, divided by 3, which is 3 meter per second square. Okay?
Yes, sir.
Now put this value of A in the second part to get the value of 10. Khalid, have you solved?
Oh, yes, sir. Done.
Send me your answer. Good, Khalid. Hamza, have you done? Good, Hamza. Hiba, have you solved? Let's say in this part, if you apply second law, which is A is equals to net force. Good, Hiba. So it will be 12 minus T divided by mass of the block, that is 1. Here we have A, which is 3. Move this A1 to the other side, so it will become 3 is equals to 12 minus T. So on solving, you will get T is equals to just 9 Newton. I'm giving you one more problem related to this. If you have 3 different blocks, let's say first block, second block, and third block, attached by string, this and this. This is experiencing a force of 15 Newton towards right, and this is experiencing a force of 3 Newton towards left. Let's say this is 3 kg, 1 kg, and 2 kg. Apply the same concept, take the entire system to be one block part, and then apply second law to get the acceleration. On solving acceleration, you will find tension by using FBD on each block part. Is it clear?
Yes, sir. Sir, can you say
Try to simplify. First of all, take these 3 different blocks as single block system. Let's say as single block system,
wait, sir.
which must be
can you tell me if I'm correct?
experiencing a right side force of, yes,
So
Salman?
you're saying we have to find the T of those both corner blocks and then find the
Yeah.
middle one. Okay.
So first of all, find the acceleration of the entire system by using these 3 different blocks as taking one block system and applying second law. After that, use FPD for A, B, C. Then you will get tension for this part as T1, tension for this part as T2, as these strings are different from one another. So for different string, tension would be different. Try to simplify it.
Sir, after doing the one block system, what to do? How to do it again?
Just try to find acceleration by taking all these 3 different blocks as single block system. So it will be 3 plus 1, 4 plus 2, 6 kg block. which must be experiencing 15 Newton towards right and 3 Newton towards left. So you will get A from here. Okay. After it,
Okay, teacher, sir.
apply FBD on first and apply FBD on third.
Then we have
So
to
here
add
we
them, right?
have,
Total.
for this part, to get the acceleration.
Okay.
Apply second law for each term. You get T1 and T2.
Sir, we have to like find that total tension, right? We will add T1 plus T2.
No, no. You have to find individually.
Oh, okay.
Salman, check your calculation. Hishma, your answer is correct. Khalid, your answer is correct. Good, Hamza. Good, Hishma. Good, Hamza. Hiba, just send me your answer. Good. So from here, you will calculate 15 minus 3, that is 12, divided by 6, which is equals to 2 meter per second square. From this part, you will get T1 is equals to 11 Newton. And from this part, you will get T2 is equals to just 9 Newton. Okay, Salman?
Sir, can you say again this 3 kg one?
If you solve this part, A is equals to net force, that is 15 minus T, divided by mass of block, that is 2. We have A is equals to 2 from the first part. So put it here, move 2 to the other side, you will get 15 minus T is equals to 4. T to the other side and 4 to the other side, you will get T is equals to 15 minus 4. So it will be just 11 Newton. Is it clear? Similarly, if you solve for this part, A is equals to T2 minus 3 divided by mass of block, that is 3. So A is 2, 3 on moving to the other side, it will be 2 into 3, T2 minus 3. 3 to 2, 6, and plus 3, it will be 9 Newton. Okay, we have just completed this horizontal motion and calculated normal reaction and tension between strings and block system. Next is to define pulley. So in this part, you have to define pulley, which is massless, frictionless, and immovable. Pulley is simply a disc or a circular disc, which I'm considering here a circular disc, which is massless, immovable, and frictionless. I'm just considering here. So on the basis of this part, we have to use some relation and derive some physical point using it. Let's say you have a pulley which is attached to any support like this. A string is going let's say if you have block this and another block this, having different masses. Let's say it is M1, M2, in which I have just assumed M1 is greater than M2. Then this M1 will pull M2 along its own direction. So it will move along downward direction and will move along upward direction. I have assumed this acceleration to be E1 and this acceleration to be E2. So first of all, you have to define whether the acceleration of these two different blocks having different masses are equal or not. For this, just use one concept. Acceleration is proportional to displacement and is inversely proportional to tension. Just use this concept. Here T is tension. For same string, tension would be same at each point, opposite to point of contact. That's why I have drawn tension at this direction. T, similarly, it will be T. Similarly, it will be T and T at all point. Is it clear till this part?
Yes, sir.
Yes, sir.
Yes, sir.
Draw tension at each point of contact opposite to it. Since string is same at each point, so tension will be same at each point. Now from here, we have tension for M1 and tension for M2, both are equal. So according to this relation, if tension is same, then acceleration of two blocks must be equal. So A1 should be equals to A2. Now, just remove 1 and 2. Now we have to calculate acceleration of this particular system. For this, just use FBD. Let's say for this M1, which is experiencing a force mg in downward direction, a tension in opposite to this particular point of contact would be T, and since whole term is going along downward direction with some acceleration A. So using second law, you would find a relation in between them. A is equals to net force. As this acceleration is going downward, so force along downward direction would be greater. So you take m1g minus t divided by mass of block A. Move this mass to the other side, you will get m1a is equals to m1g minus t. Let's say this equation to be first. Is it clear to you all till this part?
Yes, sir.
Now, if similarly you find for this M2, which is experiencing a force due to gravity in downward direction, tension in upward direction, and this block is going up with some acceleration A. So in the direction of acceleration, force would be larger. So it will be A is equals to T minus M2G divided by mass of block M2. Move this M2 to the other side, you get M2A is equals to T minus M2G. Let's say this equation to be equation 2. First of all, write it down. Then you'll find acceleration by adding these two equations, and on dividing, you will get the value of tension. Try to simplify it.
Sir, done.
Just add these two equations, you will get the value of A. And on dividing these two equations, you will get the value for T.
Sir, we have to find acceleration, right? From
Yeah.
these four equations. Okay.
Should I solve? Ashima, have you done?
No, sir. Can you solve it?
Okay, just 1 minute. We have two different equations. First one is m1a is equals to m1g minus t. And second one is m2a is equals to t minus m2g. Just add these two equations like this. You will get the value of a. Try to solve. Here we have minus t and here we have plus t. So this two term would cancel out. If you take out a as common from both these two terms, you will get m1 plus m2 is equals to, here we have m1 in positive and m2 in negative. So it will be m1 minus of m2, and I have taken gravity to be common. Now move this m1 plus m2 to the other side. You will get a is equals to m1 minus m2 divided by m1 plus m2 whole times gravity. This is your expression for finding acceleration for this pulley system. Is it clear to everyone?
Yes, sir.
Yes, sir.
Now, if you put this term to any one of the above equation, you will get the value for t. And there is another way of solving. You may divide these two equations directly. So this a and this a would cancel out. So you will get m1. Move this term to the other side. In cross multiplication, you will get is equals to m2. Now expand it. M1 times T minus, I think it would be M2. M1 M2G is equals to M1 M2G minus M2 times T. Move this term to the other side and this term to the other side. You will get M1 times T plus M2 times T is equals to M1 M2 times G plus M1 M2 times G. These two terms on adding, you'll get 2 times of M1 M2, and if you take T as common from both these two parts, you will get T M1 plus M2 is equals to 2 times M1 M2 times gravity. Move this term to the other side, you will get T is equals to 2 times M1 M2 G whole divided by M1 plus M. So this will be your final expression for getting tension in this pulley system. Is it clear?
Yes, sir.
Hamza, is it clear?
Yes, sir, it is clear.
Good. Just write it down. Have you all done to this part?
Yes, sir.
Khalid? Hiba? Done?
Yes, sir.
Now, if I ask you to find this particular tension T dash in this entire problem, so how to calculate this? In this last problem, we have T and T at this point. So from this, we have to calculate this tension T dash. So let's say this is tension T and this is tension T. As mass of this particular pulley is 0, so you can say total force in upward direction should be equal to total force in downward direction, as there is no mass of this particular pulley. So you say T dash must be equals to 2 times of T, and we have calculated the value of T as 2 times of M1 M2 G divided by M1 plus M2. So T dash would be equals to 4 times of M1 M2 G divided by M1 plus M2. Is it clear?
Yes, sir.
Hamza?
Yes, sir.
Okay, just write it down. Have you done?
Yes, sir. Done.
I'm giving you one more relation or defining you one more term. Suppose if you have a pulley, let's say at this point, and another pulley at this point. One block is here and the other block is here. This is M1 and this is M2. First of all, I have to define whether the acceleration of these two blocks are same or not. Ishma, any guess? Let me define you. For any of the term, first of all, try to define tension in the whole string. Let's say for this part, tension would be opposite to point of contact, T. At this point, it would be T, opposite to it. Similarly, at this point, T. At this point, T, T, and at this point, it would be T. Let's say at this point, it would be T dash. Is it clear to you all till this part?
Yes, sir.
Sir, in the M2 block, there's no tension?
I'm defining you just 1 minute. So it must be experiencing a tension along downward direction and a tension along upward direction at this point like this. Let's say it would be T double dash, or let's say this point to be T double dash. Now, this must be also T dash. So if you see this point, we have a pulley and two tension in upward direction and one tension in downward direction. So as I have defined you in this part, total upward force and total downward force must be equal. Similarly, you would say total upward force and total downward force must be equal. It means T dash should be equals to 2T. But for this block, that is for M1, we have tension as T only. So I have explained you in this part, acceleration is inversely proportional to tension. Is it clear? So from this, you would say, since in this block, acceleration is twice as compared to this block. So there's a relation inversely to its acceleration. So if this block is going along down direction by some acceleration A, and this block is going up by some acceleration A, this acceleration would be twice of this acceleration. So let's say this is A, so this must be 2A. Is it clear to everyone?
Yes, sir.
Hamza, is it clear? I
Yes,
find
sir.
these two terms. Or you'd say acceleration into tension is always constant. So if you move tension to the other side, you get acceleration, or you say acceleration is inversely proportional to tension. Now you have just defined acceleration of each block and tension of each block. Now use FBD and write the equation of each part. First, for M1, experiencing a downward force which is M1G, upward force tension T, and the whole term is going down by some acceleration 2A. So its equation would be net acceleration is equals to net force by mass of block. So on moving it to the other side, you will get 2MA is equals to M1 minus G minus T. Is it clear?
Yes, sir.
Hishma, is it clear?
So can you repeat once more?
I have just taken M1, which is experiencing a downward force that is due to gravity, upward force due to tension, and acceleration of this block in downward direction is 2A. So using A net is equals to net force acting on the block. So here it is, net acceleration is 2A. Net force is downward force minus upward force, and the acceleration is going down. So this force must be greater than this force. So it would be M1G minus T divided by mass of block, that is M1. Now move this M1 to the other side, you will get this equation. Is it clear?
Yes, sir.
Similarly, if you draw for this M2, experiencing a downward force due to gravity and experiencing upward force, that is T dash, which is equals to 2T. And whole term is going up by some acceleration. So you can say A is equals to, here T is stronger, So it will be 2t minus of m2g divided by mass of block m2. Move this m2 to the other side, you will get m2a is equals to 2t minus m2g as your second equation. Is it clear? Hiba, is it clear?
Yes, sir.
Salman, any doubt?
No, sir.
Now just see in these two different equations about the coefficient of tension. Are they equal or not? Khalid, check whether the coefficient of tension in these two equations are equal or not.
No, sir, they are not equal.
So how to equate them? Since we have 2t in left equation and just 1t in right equation. So
Sir,
if I
we can
multiply
multiply with
it,
2.
good. So this equation will become 4 times of m1a is equals to 2 times of m1g minus of 2t. And the second equation is just m2a is equals to 2t minus m2g. Now, if you add these two equations, this tension and this tension would cancel out and you will get easily about the acceleration of this whole system. Is it clear to everyone? Heshma, is it clear to you?
Yes, sir.
Or should I repeat?
No, sir. We are supposed to add these two, right?
Yeah.
Okay.
So whenever you have to add any of the two equations, just keep it in mind the tension or the coefficient of tension for the either of two different equations must be equal so that on adding these two terms would cancel out each other. That's why I have just multiplied this first equation by 2 so that make this tension 2t. Now add these two equations, you will get the value of acceleration, and on putting the value of acceleration in any of the two equations, you will get the value of t. Just write it down. On adding these two equations, you get acceleration is equals to 2 times of m1 minus of m2 divided by 4 times of m1 plus of m2 times gravity. Hamza, do you have any doubt?
No, sir, no doubt.
Hishma, any doubt?
No, sir.
Okay, good. Hiba, is it clear?
Yes, sir.
Have you all written till this part?
Yes, sir.
So this is about today's class. In next class, I will define you conservation of linear momentum, and then we'll start pseudo forces and then friction. Okay. So do you have any doubt from today's class to anyone of you?
No, sir.
Try to revise this entire part and try to solve the question we discussed today with your own self. Okay, we'll meet next class. Okay then, take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Thank you.